works. Oh, you know what I can do? Actually, here, this will work. Because you pronounce Q-U-A-Y, a key. How much work? Ooh. Cole, what's 1A asking me to find? Thank you. It took you a while. You're back with me. I'm going to be picking on you for quite a bit here. Yes?
Yeah.
So my first thought would be, don't write this down, don't write this down. My first thought would be to go force times distance. Cole, do you see a force in this question? You see a distance in this question. Okay, my next thought would be to go, well, maybe it's the area under a force versus distance graph. Do you see a force or a distance graph? Okay, we have our third definition of work. We called this the work energy theorem. What equation is that, Cole?
Work equals change in net energy plus change in...
Yeah. Looking at this, there's no mention of a height, so I don't think there's a change in potential. It's going to be change in kinetic. What's change in anything? So I'm going to get this, a half mv final squared minus a half mv initial squared. V final is 0 because it says stop. I'm going to get a negative answer because it's negative work. Sort of like what Cole does. Oh, that came out wrong. So it's going to be negative a half m v squared. 45 meters per second, by the way. It's pretty fast. You're doing around 150 kilometers per hour. So this would be you're speeding on the freeway and you're having to stop in a hurry. You get negative 961,875, that number there. Am I right? People nodding? So I'm going to go negative 962,000 joules. What's the minimum force of friction required? Christian, what did I find in part A? Work. What do they want me to find in part B?
Friction.
Force. Is there an equation that has work and force in it?
Yeah.
What?
Force.
Can you get to F by itself, please? Thank you.
Over distance.
So it's going to be, I'm going to write negative 962,000, but I'm going to use my answer button on my calculator, divided by 150. The negative here is optional because I'm not really asking for a direction, but I do know that the negative is telling me if the car is going to the north, the force has to be which way? South. That's what it is, which makes sense. Yeah, you're pushing in the opposite direction because you need to slow down. So I'm going to go this number here divided by 150. And I get a force of friction. Do you get 6,413? I'll go to 3 sig figs and I'll write that. Newtons. The negative, I'll give you full marks, or the positive. Either way is fine. Is that okay, Bri? Cool. Jacqueline, what C want me to find? Hey, what's mu? I don't know. What's mu with you? It wants me to find mu. What did I find in part B? Friction. So I think the first thing I would write is friction. Sorry?
I just said blessing.
Blessing him? You could do better. Mu times the normal force. So mu is going to be friction divided by the normal force. It's going to be my answer from here. I don't know the normal force. This is a job for a free body diagram. I think in this case, though, because there's no mention of a hill or anything weird, I think we can safely say that the normal force is equal to mg. So we're going to get this. I'm going to get rid of the negative by multiplying by negative 1. Divided by, what was the mass? 950? Oh. Times didn't appear. Is that okay? Do you get 0.689? Is that right? What are the units for the coefficient of friction? Are none. Okay. One of the few things that you don't need to put units for. 1 mark. Number 2, 3 marks probably means multiple steps. I like this question. I like this question. I like this question. This is a nice question. Joel, what are they asking me to figure out?
What is the minimum initial speed?
VI, yeah. When we did this in the homework, I asked, should they be charged? And we agreed that we needed to find VI to figure out what they should be charged. Here I'm just saying, let's find VI. How did I do this one? I started out kind of weirdly, Joel. I started out by saying work equals work, which I would defy you to argue is wrong. That must be right, right? There's 2 ways I'm going to write work. I'm going to write force times distance, and I'm going to write change in potential plus change in kinetic. No graphs. I'm not going to be using that one. And then, Joel, we said, I think looking at this question, it implies that the road is flat, so there's no change in height. What's change in anything? It's on the tip of your tongue, I know. Psst.
Oh, final line.
There, I knew it was on the tip of your tongue. Okay, so what's changing anything? Final. Now, if you blank, if you add that to your green sheet, you can. Next year, I won't let you add it to your green sheet. Physics 12, I don't let you add anything to the formula sheet, but in Physics 11, I'm not too fussy, but I'm trying to wean you and get you to be able to derive more stuff in your head. Again, it's a much better way to be here than memorizing a bunch of useless stuff. So, I'm going to write this as force times distance equals a half mv final squared minus a half mv initial squared. Joel, why can I cross out v final? What's the final velocity of every car accident in history? Yeah, okay. Which we've agreed makes sense. Okay. There is a negative right there. See it, see it, see it, see it, see it? I'm going to chuck that because this wants the speed. Technically, I should introduce a negative right there because the force is in the opposite direction of the motion. But rather than do that, I'm just going to clue in and say speed is a scalar. It's going to be positive. So how would I get the v by itself? Times by 2, divide by what? M? And that's going to give me v squared. Joel, how to get rid of a squared. So I'm going to get this. You want to know, and again, if any of you get involved in RCMP or crime scene or accident investigation, I bet this equation is in the notebook of things that they have to fill out. I'm going to get minimum speed is 2 times force times distance divided by m, square root. Oh, got a problem. Which force? Friction. Friction is what times what? Okay, so over here I'll make a little note. Friction equals mu times the normal force. So this is going to become square root of 2 mu normal force times distance over m. I don't know the normal force. Oh, wait a minute. What can I safely say the normal force is equal to? And this is where we notice the m canceled. We could have actually put in mu mg on this line and canceled the m's out right here, but the m's do cancel. Here's what I get. This is what we got in our homework. We ended up with vi equaling the square root of 2 mu g d. So let's find out what we get. It's going to be the square root of 2. What's mu? 0.55. G 9.8. D 52. 2 times 0.55 times 9.8 times 52. You get 20, oh, yeah, square root 23.7, is that right? Lining. 23.7 meters per second. If you got that, 3 out of 3. Otherwise, I would probably give you 1 mark for that line. I'll probably give you 1 mark for that line. I probably, well, you know what? Like I wouldn't. I would give you 1 mark if I saw that. 1 mark for the answer, something like that. Then I would turn the page. Ooh. Christy, looking at the picture, do you see a change in height? Do you see a change in speed? Do you see a yucky, curvy path? Without even reading the question, I'm already thinking this might be a job for the law of conservation, of energy. I'm just guessing here. Wants how fast is the child traveling at the bottom? Yeah, I'm going to start out by going KE initial plus PE initial equals KE final plus PE final. Plus heat. Oh, no. It says ignore what? Are any of these 0? I think at the bottom. But nothing else is 0, sadly. So we're going to get a half mv initial squared plus mgh initial equals a half mv final squared. Ooh, Christy, is there an m in the first term? Is there an m in the second term? Is there an m in the third term? Is there an m in everything? Can grown-ups and little kids go on the same water slides? Yep. Why? Yes, cancels. We're trying to find v final. I'm going to do one more clever thing, Christy. I'm going to go times by 2, times by 2, times by 2. You don't have to. You could divide everything by 0.5, a half, and square root right now. I'm a math nerd, though. I know if I do this, that'll cancel, and I'll get a prettier equation. I'll get vi squared plus 2ghi equals vf squared, and I've managed to clear my fractions. What do I want to find, Christy? Which v? I got a squared. Joel, how to get rid of a squared? So you're telling me I would do this? You'd be right. V final is going to be the square root of, what was VI? 8.3 squared plus 2 times 9.8 times 21. 8.3 squared plus 2 times 9.8 times 21. Square root of that. Do you get 21.9? 22? People nodding? Meters per second. Suppose this child is only traveling at 16 meters per second at the bottom. How much energy was transformed into heat? We're going to redo the question, Christy, but this time we're going to add heat. We can still safely say that potential final is 0, because MGH there is 0. How would I get the heat by itself? How would I move this KE final over? Divide or subtract? Subtract. Yeah, people like to divide that one for some reason. I don't know why, but they do. So, Mateo, you're correct. You're telling me heat is going to be the KE initial would just drop down like a domino, and the PE initial would just drop down like a domino, minus KE final? Yeah. Okay, let's plug and chug. Heat is going to be a half mv initial squared plus mgh initial minus a half mv final squared. Is there an m in the last term? Yeah. Is there an m in this term? Yeah. Is there an m in this term? Yeah. Is there an m in heat? So if I allow for friction, Maggie, does mass cancel? No. But in real life, as long as friction is really small, the mass, although it doesn't cancel, Chloe, it's negligible, which is why little kids and grown-ups can go on the same water slides, because there's not that much friction between you and the water. So, 0.5 times, what was M, Mr. Dewick? 45 times 8.3 squared plus 45 times 9.8 times 21 minus 0.5 times 45 times 16 squared. You get 5,051 point. You get that? So I'm going to go 5,050 joules of heat. Technically, I should go to 2 sig figs, so technically I should call this 5,100 joules of heat because there is a 5, and so I'd round the 0 up to become a 1. If you get that, 4 out of 4, 4 marks. Oh, I forgot to do part marks for both of these. 1, 2, 3, 4, 5 lines. I would probably go something like this. 1 mark for that. I would probably go 1 mark for that, 1 mark for the numbers, and 1 mark for the answer. I'd probably do something similar here. 1 mark, 1 mark, 1 mark, 1 mark. Then I would turn the page or go to the next page. I see a change in height. I see a change in speed. I see a yucky curvy path. I'm betting this is conservation of energy. Yeah, what's its, roller coasters. What's its speed at the bottom of the hill? This one, Oliver, is a little nicer. They did say from a standstill. So, kinetic initial plus potential initial equals kinetic final plus potential final. That's 0, that's 0. This isn't too bad. I'll end up with mgh initial equals a half mv final squared. Yay, yay. Don't be doing it now too. Don't do that. Pardon me? No. Just decide you won't and you won't. Cool, how would I get the v by itself? It gives me a v squared. So it's going to be 2 times 9.8 times 90. $42. It's not a bad coaster. If you got that right answer, 2 out of 2. Otherwise, I'd probably go half mark, half mark, half mark, and then a half mark for the answer. How fast will the coaster be traveling at the next hill? There's 2 ways to do this. The long way and the easy way. I'll show you the long way first. The long way would be to say the change in height is a change in speed, there's a curvy path, this is a job for conservation of energy, G. Although the short way starts with this same routine as well. Are any of these 0? Well, you're starting at rest. Are you ending up on the ground? And they want us to get V final, which is hidden right there. And you could do that. You would go mgh initial equals a half mv final squared plus mgh final. You could say, yay, m cancels. You could go gh initial minus gh final. That equals a half v final squared. Times by 2, divide by, no divide by, times by 2 square root. Look up, here's a great trick. How high? How high? One of the nice things about energy, because it's a scalar, I can put the ground wherever I want to. I'm going to put the ground right there. Now how high is point B? No, not if I put the ground right there. How high is point B? 0. How high is this part here? 40. And I can do this, starting out the same way. KE initial plus PE initial equals KE final plus PE final. But what's nice about this is that still cancels, but now that cancels. It's way less writing. I'm going to get MGH initial equals a half MV final squared. Rihanna, M still cancels. I'm going to get V equals 2 times G times H initial. The big difference here, Cole, is H initial is not going to be 90. H initial is going to be that height in your head. Yeah. This will work. Which one is less writing? The clever one. Yeah. 2 times 9.8 times 40 square root. I think this might even work out evenly. Oh. Yeah, 28. Now, I knew I was going to be going slower at the top of the second hill than I was at the bottom of the first hill. So there's a bit of a built-in error check. I knew it was going to be less than 42. If you did it this way as well, Mateo, you should have got 28 as well. If you didn't, you made a math mistake. I like number 5, I like number 5, I like number 5. Number 5 is the next question. How much work? Well, work is force times... Oh, they did give me a force and a distance. Looks like it's 130 newtons and 0.7. Can I do that one on my head? Maybe. 100 times 0.7 is 70. 30 times 0.7 is 21. 91? Is it 91? That's how much energy you stored. That's how much work was done. If we assume all the potential is transformed into kinetic, I think we can say this. 91 joules equals a half mv squared. Because it all got turned into kinetic. How would I get the V by itself? How do I get the V by itself? Times by 2 divided by m square root. Cool. Times by 2 divide by m 0.0186 square root. 2 times 91 divided by 0.0186 square root. 98.9. Ballpark, does that seem right? Yeah, I'll bet you a good compound bow can fire an arrow fast enough that it'll go almost one football field in a second. I can follow it with my eyes, but that's really fast still. That seems to me what a bow and arrow combination can pull out. One mark. Half mark. Half mark. Ooh. Heat. Okay. Kinetic initial, potential initial equals kinetic final plus potential final plus heat. Now here, potential is the energy from the pull, not from gravity. So my final potential is 0, my initial kinetic is 0, and I want to get the heat by itself. It's going to be potential energy initial minus kinetic energy final. That equals heat. Potential energy initial was 91 minus a half m v squared. We lost 64.8. Is that right? People nodding, nobody nodding. Am I right? 64.8 joules to heat. 64.8 joules. My angels, that's a quiz on a little bit of everything. Can you give yourself a score out of 23, please? Big review that I just gave you. Unit 7 review. So I stole this from another teacher, but here's kind of a review part of what we've been doing. So you'll see there's work, force times distance. The net work is what you get when you combine works, but if the work is in the opposite direction, you're combining a negative, you're losing energy. Power is work over time. The work energy theorem. Potential energy is mgh, kinetic energy half mv squared. Efficiency, law of conservation of energy. So, you can cross out number 4. You can cross out number 6. Yeah, 7 I'm not a fan of. So 4, 6, 7. 8 is good. 9 is good. 10 is good. 11 is good. Ooh. What kind of a graph do you see in number 12? A what versus what? I'll bet you the area underneath this graph is the work. So when it says moving from 20 to 60, it's probably that area there, which looks like a trapezoid to me. So that's good. Let's cross out number 14. 16 is good. We can cross out 17. That's good, that's good, that's good, that's good, that's good. That's good. 24 is good. I think I like the rest of these. But let me just read a couple more here. Yep. So I'll give you the rest of the class to work on this.